Alright, geometry, this is Longo here, and I am about to make a quiz review video for you because you guys said you would use one. So, I'm going to tell you that I would highly recommend against just watching this video. If you want to take full advantage of what a review is supposed to be, you will print this out first and try all of the questions on your own. Then watch the video, because if you get most of them right, you should feel pretty confident. If you find out that you got most of them wrong, then you might want to, again, try this after you watch it, and try it again. Alright, so let's do this. Pause the video, go do this on your own first, if you haven't. Otherwise, let's get going. When you simplify radicals, remember I've suggested that you divide by the smallest number. So 54 divided by 2 is going to give you 27. That's going to give you 3 and 9. Then you have your 3 and 3. When you circle in pairs, it goes outside of the radical. When you box leftovers, those stay inside the radical. But do not forget about the 4 that's already outside. He has to stay outside. Then you multiply. 4 times 3 is 12. Root 2 times 3 is 6. Remember, I showed you in class how you can type both of those, the original and your simplified answer, in your calculator. It'll give you the same decimal. When you're multiplying, it is allowed to multiply the outsides. So 2 times 3 is 6. And the insides. 8 times 6 is 48. Break down the 48. You got 2 and 24, 2 and 12, 2 and 6, 2 and 3. You have 2 groups of 2 that get to go outside, so you have a 2 and another 2. Do not forget about the 6 that's already outside. Root. Box just the 3. And then 2 times 2 times 6 is 24. Root 3. And you are good to go. When you are dividing, remember the rules for dividing. You cannot have a radical in the denominator. So you need to multiply the top and bottom by that square root of 3. Just like multiplying, 5 times the square root of 3 is 5 root 3, because you have to keep outsides and insides separate. The square root of 3 times the square root of 3 is the square root of 9, and we all know that the square root of 9 is 3. So you get 5 root 3 over 3 for an answer, and yes, you just leave it that way. Last example, when you add radicals, the inside must be the same. So as soon as you see that they're different, you do not say they cannot be added. What you need to do is see if you can simplify one of them. The 12 can be simplified to 2 root 3. So 2 root 3 with the 2 out front already. This is technically 4 root 3. So 5 root 3s plus 4 root 3s is going to give you 9 root 3s. Okay? So that's your review on combining like terms, multiplying, simplifying radicals. Now we're going to move to 30, 60, 90, 45, 45, 90. The most important part of these questions is knowing where each side is located. So with 45, 45, 90s, the legs are always L and the hypotenuse is always L root 2. So if you'd like a suggestion when you start your quiz tomorrow, just label all the 45, 45, 90s first. And then in your 30, 60, 90s, opposite of the 30, the side that's not touching the 30-degree angle is always your shortest side. So if this is your 30-degree angle, all the way across from it is your S. So then this is your S root 3, and this is your 2S. In this problem, if that's your 60, this is your 30. So this is your S, S root 3, 2S. And over here, this is your S, S root 3, and 2S. Alright, so now everything is labeled. So then what you want to do is you want to take what's given, the given side. So we see that L root 2 is equal to 5. To solve for L, you just have to divide both sides by the square root of 2. And now that we've already covered dividing radicals, 5 divided by the square root of 2 is going to end up being 5 root 2 over 2. So that is what L is now equal to. So everywhere you have an L, you have a 5 root 2 over 2. So this leg is 5 root 2 over 2, and so is this leg, 5 root 2 over 2. Our next example goes to 30, 60, 90. So if we take our given sides, we now have that s root 3 is equal to 4 root 6. To solve for s, you just have to divide both sides by the square root of 3, and you end up with s is equal to 4 root 2, because root 6 divided by root 3 is root 2. So plug that in, and we have an s. So s is equal to 4 root 2. And a 2 times s would be 2 times 4 root 2, which is 8 root 2. Okay? Those are your two missing sides for that guy. Next one. This is the easiest situation, is when you're just straight up given L. L is already 6 root 3. Hooray, you're done. So this L is also a 6 root 3. And this L is a 6 root 3, but you have a root 2 after it, so this becomes 6 root 6, because you multiply the insides. Next row, you have a 2s, which is equal to 14. So you set 2s equal to 14, divide both sides by 2, and you get s is equal to 7. Once you have s is equal to 7, you plug it into all your s's. Here's an s, there's a 7. Here is an s root 3, so here is a 7 root 3. And again, you are done with that guy. Next one, we have an L, which is equal to 10 root 2. So this is another one of those nice examples where it's already done for you. So you have a 10 root 2 is equal to L, so here's another L, so here's a 10 root 2. Here is an L root 2, so you have a 10 root 2, which happens to be 10 root 4. But of course the square root of 4 is 2, so this one actually simplifies all the way to 20. And our last example is s is straight up given as 8 root 5. Again, this is the nice one. So s root 3 would be 8 root 5 root 3, which is 8 root 15, because you multiply the insides. And 2 times 8 root 5 is going to give you 16 root 5. All right, so that pretty much takes care of everything that you need to know about 45, 45, 90s and 30, 60, 90s. Remember, placing your L's and L root 2's and S's and 2S's and S root 3's is the most important part. After you got that, it's just working with radicals. Last 3 questions on the review are applications that are just go a step beyond. So the first example, I'm telling you that is a square and you need to find the perimeter. So if a square is just two 45, 45, 90s joined together, then you're going to use your 45, 45, 90 stuff. So this is L root 2, this is L, and this is L. So given L root 2 is equal to 10, you have to divide both sides by the square root of 2. And you will find that L is equal to 5 root 2 once you divide 10 by the square root of 2. Remember, you have to multiply the top and bottom by the square root of 2, which gives you 10 root 2 over 2, and that's how you end up with 5 root 2. So every single one of these legs is 5 root 2. That's 5 root 2, this is 5 root 2, and this is 5 root 2. So 5 plus 5 plus 5 plus 5 is 20 root 2's. And if this was given in inches, of course, you would need to put inches because we are talking about a perimeter. The next one, the perimeter was given. So in this equilateral triangle, we're looking for the altitude. So the first thing you're going to want to do is draw in your altitude. So remember, equilateral triangles are all 60-degree angles until you split one, so that becomes a 30 and a 30. So an equilateral triangle is just two 30, 60, 90s joined together. So this is your S, this is your S root 3, and this is your 2S. So if the perimeter was given as 30, then all of your sides are 10, 10, and 10 for the whole thing, which got split into 5 and 5. So we can see that S is already 5, so your altitude is just going to be 5 root 3. And your last example is where they're joined together. So you have a 45, 45, 90, which has an L, an L, and an L root 2. And on the right side, you have a 30, 60, 90, so this becomes your S root 3, and your 2S. So in order to work through this question, you must start with the left. So L root 2 is equal to 6. So when you divide everything by the square root of 2, you're going to get that L is equal to 3 root 2. So this guy right here is 3 root 2, and this guy right here is 3 root 2. But now that you are in the other side, that's now S. So this side, S, is equal to 3 root 2. So hooray, you're already done. This side is still 3 root 2. That side cannot change. So this side is 3 root 2 with a root 3. So X is going to give you 3 root 6. And 2 times your S, which is 3 root 2, is going to give you 6 root 2. All right? So that is an awesome review. It's going to handle everything that you really need to know for the quiz. There is one application problem, but it's pretty much just the same as what we just got done doing. All you have to do is pretty much draw your own picture. All right? So this is Longo, and I'm out. See you, bye.